These were the 4 features that Rutherford put forward in his model. You can pause the video to go through each of them. Alright, the first, second and fourth feature holds very true, but the third feature was a little problematic. This one right here was a little problematic. It said that electrons revolve around the nucleus in circular paths. So let's have a look at an atom. Here is your nucleus. This right here is a nucleus, and this is an electron moving in circular path, revolving in circular path around the nucleus. Now, any object that moves in a circular path experiences a force towards the center. In this case, you can see that the nucleus it's always positively charged, electrons are negatively charged, and unlike charges attract, right? So there will be a force towards the center which will be experienced by this electron. And if there is a force towards the center, there will be an acceleration towards the center. And that is also something that you will learn in physics in much more detail, that every object that is moving in a circular path, even if it is moving with the same speed, is undergoing an acceleration. And why is that? Because they can say that acceleration is really change in velocity, right, per unit time. Over here, the speed might not be changing, but the direction is constantly changing, right? The direction in which the electron move, it constantly changes. So as a result of that, there must be some acceleration, right? Because there is change in velocity. Now, why is it towards the center? Well, there is, we won't really go into that right now, but you can say that because there is a force being experienced by the electron which is directed towards the center, there must also be an acceleration in that direction, right? The same is true for any system really which is undergoing a circular motion. Let's say if you have a ball tied to a string and you are making the ball go in circles. In this case, imagine what is the force that is experienced by the ball. Well, you're not holding the ball directly, right? You are holding it through a string. So the tension force in the string, that force is keeping the ball go in circles. And if there is a force towards the center, there will be an acceleration towards the center as well. Whenever there is a force, there is an acceleration. Again, if you're not familiar with that, you will learn more of that in physics. So now every object undergoing a circular motion has an acceleration towards the center, and that acceleration is really called centripetal acceleration. The same is true for the electron moving in a circular path over here. Now, if a charge is accelerating charges, they radiate energy. And what form of energy can they radiate? Well, they can radiate energy in the form of electromagnetic radiation. For example, radio waves, microwaves, and any kind of electromagnetic radiation. But if the electrons are constantly radiating or losing energy, then they must really lose their speed, right? They're losing energy. They can't keep on moving in a circular path around the nucleus because they are constantly giving away energy. So they must really spiral. They must spiral like this, and then strike at the nucleus. Well, that will make the nucleus highly unstable. So how does an atom exist at all? This was the biggest drawback of the Rutherford model, which his model couldn't really explain that. And later on, the scientist Niels Bohr, he came up with a new model, a new structure of an atom, which explained how electrons can move, how electrons can revolve around a nucleus.